All right, so in this lesson, we're going to solve linear quadratic systems. First of all, a system is where we have more than one equation that we're trying to solve for. So in our bell work number 1, that was a system because we had 2 equations, k plus p equal to k minus p equal to -4. So we solved that system because we figured out what both variables were in that equation, what they had in common. Those were 2 linear. We're going to solve where one of our equations is linear and where the other is quadratic. So we have worked with 2 different types of quadratic equations to this point. We've worked with circles and we worked with parabolas. There's several other quadratic systems. There's an ellipse, there's a hyperbola as well. We haven't talked about those. But we're basically trying to figure out where those 2 things would intersect. So if, for example, we had a circle and a line. Wait a second, I'm going to do something really cool here. Whoops, let's do that. Okay, so if we had a circle and a line, whoa, all right, there we go. So how many points can a circle and a line intersect? Right now, how many are they intersecting at? So you have no points in common. How many points do they have in common here? 1. How many there?
2.
The max they could have would be 2, or they could have 1 or none. Okay, so then our other what we've looked at is parabolas from this direction or that direction. And again, if we have, we could have a line and a parabola intersect in how many right now? 0, 1, or 2. The max would be 2. Least amount would be 0, 1, and then 2. Okay, so what we're going to look at, there's 2 ways to determine what the solution is for linear and quadratic equations or systems. We can do it graphically, or we can do it algebraically. Today we're going to work on the algebraically method to solving linear and quadratic systems. Okay, so we're going to do the algebra, then we'll go back and look at the graphs and see how that works. So today we're going to do algebraically. All right, whoops. Ooh. When we're talking about a system, they will put that squiggly out front saying they're together. That's a system of equations. So we want to solve this system. We want to do something similar to what we did on our bell work number 1, where we want to add and eliminate one of the variables, if we can do that. If we can't do that, then we'll look at the substitution method to solving. So right here, I see that I have y and y. I just need one of those to be positive, right, in order to add and cancel. So what I'm going to do is I'm going to take the first equation times a -1. And then that will make that a positive y. So whatever I do to one thing in that equation, I have to do all the way across on that equation. So that's going to give me a -x plus y equals -7. And then the bottom equation stays the same. It's x squared minus y equals 7. And now if I add the 2 equations, the y's cancel, correct? So I'm going to have a -x plus x squared. I'm going to put the higher power first, so that's x squared minus x. The y's cancel, and -7 plus 7 is also 0. Okay. All right, so we have actually x squared minus x plus 0 equals 0. We have a quadratic equation. I don't know if we've talked about factoring a whole lot in here just yet, so we're going to use a quadratic formula. Remember, it's opposite of b plus or minus the square root of b squared minus 4ac over 2a. Because we're trying to solve this equation. We're trying to find x, and then we can find y. All right, so we have everything on one side equal to 0. We can identify a, b, and c. So in this equation, what is the value of a? It's what's in front of x squared. How many x squared do we have? 1. So that's 1. B is what's in front of the x to the first, and that is a negative 1. And then c is 0. So our work's going to be cut down a little bit because the value of c is 0. So we're going to plug that information into our formula up here. So opposite of b, that would be opposite of a negative 1 plus or minus negative 1 squared minus 4 times 1 times 0 all over 2 times 1. That's 1. Okay, so we found the value of x, two values of x. X is 1 or 0. So now we need to figure out what y is, because remember, solving a system means we're finding the values of each variable, where they intersect, the points. So we're going to use, when x equals 1, we're going to pick one of the two equations. I'm going to use the one that doesn't have the x squared, because I don't know, it's just simpler for me. So in that equation, I'm going to let x equal 1. So I'm going to use x minus y equals 7. And I'm going to let x equal 1. So that gives me 1 minus y equals 7. Then I'm going to subtract 1. So I get negative y equals 6. So that means y is a negative 6, right? Because I would divide by negative 1 to get y. So that gave me the point. This is so jumbled, but that's the way it is. I started with x equaling 1, right? And I got negative 6 for the y value. So there's one point of intersection of those two things. And this would be a line. The equation below would be a parabola. So we have 2 points where the line and the parabola are intersecting. We found one of them by letting x equal 1. We have a second value of x, so we've got to use that as well. So we're going to let x equal 0. I'm going to use the same equation that I used for when x was 1, x minus y equals 7. But I'm going to plug 0 in this time. So 0 minus y equals 7. Negative y equals 7. So y is a negative 7. Divide by negative 1. So that I started with the value of x equaling 0. When I plugged it into the equation, I got a negative 7 for y. So that point is also a point that those two graphs have in common. So the line and the parabola are going to intersect in 2 points, and it's going to be those 2 points. All right, some systems are going to lend themselves easier to subtracting things out. Some are going to be easier to use a substitution for. Here, the second equation, I got a lot going on there. I'm going to use substitution because adding is, let's just use substitution so you know what to do there. So on the first equation, what I'm going to do is I'm going to solve for y because x is in this mess on the bottom right here. I'm going to plug something in for that y. So I'm going to use on the first equation, I'm going to get y by itself. So over here, I've got 3x minus y equals 7. I'm going to add y. So I get 3x equals y plus 7. Then I'm going to subtract that 7 to get it over on the other side. So that gives me the equation y equals 3x minus 7. So I'm going to go to the second equation, and wherever I see y, I'm going to put this in its place. So right here, I'm going to put 3x minus 7. So let me, So now I'm going to, for the y, I know y equals 3x minus 7, so I'm going to put that there. Then I still have that plus 4 equals all that good fun stuff on the right. Okay, so I use the first equation to isolate y so that I could substitute that into the second equation. So then I would only have one variable in the second equation. Notice I don't have any y's left in my second equation. I just have x. So that's going to allow me to solve for x. So I'm going to simplify the left. 3x minus 7 plus 4 is 3x minus 3. And I have to simplify that x minus x plus 5 squared in order to solve. So I'm going to write that as x plus 5 times x plus 5. And what's the key word that we talk about when we multiply things? Two binomials. Multiply through, we call it foiling. Foil, first, outside, inside, last. So that's what we're going to do with this parentheses here. We're going to take x times x. And that gives me x squared. Take x times 5, 5x. Then I'm going to take the insides, 5 times x is also 5x. And then 5 times 5 is 25. Bring that 2 down, equals 3x minus 3. And in the parentheses, what can I combine? The 5x's. So 5x plus 5x is 10x. So I'm going to have 3x minus 3 equals 2 times x squared plus 10x plus 25. Now I need to get rid of the parentheses, so I'm going to distribute the 2 through, get everything equal on one side, equal to 0, and then I'm going to use quadratic formula. Alright, so now that I've got it equal to 0, I can identify a, b, and c and plug it into the formula, quadratic formula. So a is 2, b is 17, and c is 53. So opposite of b. Negative 17 plus or minus the square root of b squared minus 4 times a times c over 2 times a. And this is solving for x. We're trying to find x. I need a value for what's under the radical. Somebody simplify that for me. 17 squared minus 4 times 2 times 53. Okay, because we get a negative under the radical, that's going to give us I as in our solution, right? Can we graph I on the coordinate plane, on the xy coordinate plane? Can we graph imaginary? That's just for real numbers. So anytime we are working these out and we get a negative under the radical, meaning we would have an imaginary solution, that's where they will not intersect. So that would be an example if this is a parabola and a line, they will never intersect. So our answer is just no empty set, no solution, they don't intersect. There's no point of intersection of those two lines or equations in the system. Okay, let's do another one.